Polymers for Transport by Samuel Bennett. Transportation is extremely important in the 21st century and is used by nearly everyone. It's used to travel to our jobs, visit other countries, export and import goods from other countries, and even travel from East Campus to West Campus at a university. Transportation is used constantly. However, none of this would be possible without polymers. Polymers are used in everyday vehicles, constantly improving their performance. However, before I discuss how some polymers have been used in transportation, you need to understand what a polymer is and how they're actually made. A polymer is a large chain of repeating units. These small units are called monomers. Polymers are made by connecting these monomers in polymerization reactions, which will be explained further in a minute. Now, polymers can vary in length, with some being 10 units long and others being thousands of units long. The chain length, among other things such as the type of monomers that make up the chain, the architecture, and the stereochemistry of the polymer, can affect the properties of the polymers. This therefore affects the polymer's applications. As stated before, polymerization is the reaction of joining monomers to form a polymer. There are two main methods of synthesizing polymers, which are chain growth and step growth polymerization. In chain growth polymerization, monomers are added one at a time to the end of a growing polymer chain. This can be seen below as bonds form as stated above. In step growth polymerization, both monomers and growing chains have reactive groups, and all species can join to form long chains. In the animation shown below, you can see both monomers and growing chains reacting to form one huge chain. In all chain growth polymerizations, there are three common steps. Initiation. This is where a reactive species known as the initiator is formed and reacts with the first monomer to generate a reactive polymer end group, as shown in the image that appears. Propagation, where the reactive end group reacts sequentially with further monomers, leading to extension of the chain, as shown in the image. And finally, termination. The reactive end group is deactivated, ending the polymerization, as shown in the image that is appearing now. How the reaction is terminated depends on the type of chain growth polymerization. The example shown is known as free radical polymerizations, which is a type of chain growth polymerization. Now, just to briefly mention something about step growth mechanisms. Step growth doesn't need to rely on chain reactions, as any of the species in the mixture can react with each other. Now, as stated at the start, a large number of polymers are used in everyday transport. For example, in planes, a polymer known as epoxy resin is used as an adhesive when constructing the plane. Also in bicycles, the inner lining of the tire is often made of Kevlar, which improves the strength and durability of the tires. The structure of Kevlar can be seen in the top right. However, when talking about transport, the vehicle that most people think about is cars. Polymers are used in many components that make up cars, and the amount of polymers used in cars has increased over the years as shown by the graph in the top right. The average car uses about 150 kilograms of plastics and plastic composites, which is about 10 to 15% of the car's weight. Up to 13 different polymers can be used in each car model, making up many important components of the car. However, the main plastic used are polypropylene, polyurethane, and PVC, also polyvinyl chloride. Polypropylene is a very useful polymer and is made from the monomer propylene. The monomer, propylene, can be seen in the top right of this slide. Polypropylene is often used to make automobile bumpers, as well as some of the chemical tanks within the car. Polypropylene is one of the lightest plastics available, with a density of 0.905 grams per centimeter cubed. This is useful as it makes the components it's used in lighter and therefore overall making the car more fuel efficient. It's also extremely chemically resistant, which is why it's so useful to make the chemical tanks from polypropylene. Polypropylene is produced via a chain growth polymerization reaction involving the monomer propylene. The reaction is generally done with suitable catalysts, which are usually aluminium alkyl and titanium tetrachloride. The reaction is shown in the image below as well. For the industrial production of propylene, there are two main ways to produce it: the bulk polymerization and the gas phase polymerization. One of the reasons it's so useful to make the bumpers from this polymer is because it's very easy to mold, and there are many different methods to form the components that are made from polypropylene. Polyurethanes are a large family of polymers with a wide range of properties. The main unit of polyurethane can be seen in the top right corner. Due to these many properties, the principal applications of polyurethanes in cars are in coatings, elastomers, and foams. Polyurethanes have good abrasion resistance, making them durable materials to use in cars. They are also often used as insulation in cars. As stated before, polyurethanes are used in foams, and specifically in cars as the flexible foam seating and the foam insulation panels. Polyurethane elastomers are specifically used in certain parts of the automobile and the steering wheel. Now the synthesis of polyurethane is fairly simple and is formed from step growth polymerization. In this process, a molecule containing at least two isocyanate functional groups reacts with another molecule containing at least two hydroxyl or alcohol groups in the presence of a suitable catalyst. As shown in the image, the isocyanate functional group reacts with the hydroxyl group to form a bond between the two molecules, forming the basic unit for the polyurethane molecule. This carries on until the polyurethane chain is formed. Now PVC, or polyvinyl chloride, is used in the protection of the bottom floor in the car and for the internal lining and coating of electric cables in the vehicle. It's useful for making car components due to the wide range of manufacturing procedures it can undergo to make the components of the car, for example injection molding. PVC is a good absorbent of impacts and vibrations, which is why it's used in the protection of the floor. It's also a very safe material used in cars as it has a low flammability. It's used for the coating of electric cables as well as it's a good insulator. Finally, it also has good resistance to chemical and solvent attacks, making it even better for the protection of the floor of the car. PVC is formed from free radical polymerization, which is a type of chain growth polymerization and therefore has the three steps as stated at the start: initiation, propagation, and termination. In the initiation step, the initiators that are used to start the polymerization of vinyl chloride are dioctanoyl peroxide and diacetyl peroxidicarbonate. The polymerization of the vinyl chloride reaction can be seen in the top right. Now, in the future, the use of polymers in both cars and other forms of transport will continue, helping to take the performance of these vehicles even further. As research carries on, lighter, stronger, and overall better polymers will hopefully be discovered, improving fuel efficiency even further and making vehicles even safer. Here on the final slide are all the sources I've used for this investigation if you are interested in looking at the research done on the subject of polymers and transportation. Thank you for listening, and I hope you enjoyed this presentation.